All right. Good evening, fellows. How are you? Having a good day at reInvent so far? It's been a long day, right? Yeah. So many sessions, so many breakouts, workshops. I hope you're enjoying all of it. So we are almost at the end of the day, and this is a topic that's really, really common in the conversation I have with my customers. The talk about how do you essentially build reference architectures that allow you to combine data sources that are generating data at different frequencies, right? It's a very common problem. You've got your data warehouse that's having batch data that's not as frequently refreshed as something that's generated via a sensor, for example, right? The real value is to combine the two and then draw holistic analytics that allow you to connect batch and stream, and that is what we are precisely going to talk about today. So just for information's sake, this is a chalk talk, and the format is essentially about going deep on a particular architecture, and then the presentation portion is really, really short, so it's about 20 minutes where Rajiv and myself are going to talk about the architecture, but the rest of it is kind of open to you all to ask us questions, and we'll see how many we get to today in the time constraints we have, but we'll try to do as many as possible. So just to introduce myself, my name is Ujjwal. I know for some of you it might be a tongue twister, but that's what my name is. It has a meaning, by the way. But I am a solutions architect at AWS. I have a specialty in healthcare and life sciences. So I work with providers, payers, farmers, genomics organizations who design workloads on AWS. And on the technology front, I'm big data and analytics, AOD, area of depth, SA. So I kind of concentrate on workloads that are at the intersection of healthcare use cases, but involve large-scale data processing. So if any of you are from the healthcare background, feel free to reach out and ask questions about how particular scenarios apply to healthcare workloads. So I'll be happy to talk to you. And then the other thing that I wanted to say before I hand it over to Rajiv is we couldn't get the soft whiteboard that actually allows us to write something here and it gets projected on the screen, because this was supposed to be a breakout session room and not a chalk talk room. The logistics didn't allow us to arrange for the soft whiteboard, so I apologize for that. If you do have a questions where we need to actually draw something here, I request you to please come forward and ask that question so that if we are ever drawing something, you can probably come and see. And I'll try to keep it as large as possible so it's visible. So with that, I'll hand it over to Rajiv, who will take you through the first part of what we're going to talk about, and then I'll come in the end and wrap up the presentation. Thank you.
Thanks, Ujjwal. Check. I hope all of you are having fun. And I just want to add one more piece, is that there is also a repeat of this chalk talk. So if your friends or colleagues couldn't make it today, then there is a session of the repeat session of this chalk talk on Friday. So let me start by introducing myself. I'm Rajiv. I'm an AWS solution architect, and I focus on big data. I love more hands-on coding and doing big data solutions and having fun with analyzing data and writing Spark queries and optimizing queries and query performances. So, and this is something that I see where there is a need for handling or balancing both the volume of data and velocity of data. So, what is this talk about, right? Just by show of hands, before I get into that, are there any data scientists, data engineers, or data architects in the room? Please raise your hands. Okay. How many of you are developers? Any developers in the house? Okay. Lots. Cool. So as developers or data architects, data scientists, we all know that whenever we are collecting data and when we process that data, there is a significant delay because of the volume of data between the time that we collect the data to the time where you can actually visualize some meaningful insights from that data. So And why is this lag? And why do we see this significant lag? That's because we want to be able to do a accurate and comprehensive analysis. And with large or massive volume of data, this delay keeps on increasing further and further. So that's one kind of use case where accuracy is important to you. But then there are use cases where it's not, you have to instantly react to the data. Accuracy, maybe you can compromise a little bit on accuracy, but you have to instantly react to the data as you are collecting it, and as or as it lands in your Hadoop cluster or your EMR cluster or any kind of cluster or data processing or analyzing engines that you have. So how the biggest challenge as data engineers, data scientists, or even sometimes as big data developers we have is, how do I balance both? How do I make sure that I'm able to address both the volume of data and the velocity of data? And the answer to that is the Lambda architecture. And this is the one that I have here is the Wikipedia definition. There are lots of other definitions out there. This is the definition from Wikipedia. And the Lambda architecture is a unified single framework that actually helps you to address both the volume and velocity. That means you are able to address or do a comprehensive analysis and address the accuracy that you need, and at the same time being able to react to the data as soon as the data lands. Another point to note that this is not to be confused with the AWS Lambda. And whenever we have some AWS Lambda service as part of this architecture as well, so we will be explicitly calling that as AWS Lambda. So whenever we say Lambda architecture here, it means the common architecture of data processing that's out there. And as I move along on the slides, you will see how to deploy this Lambda architecture on AWS. So that's what all this talk is going to be about, and how you can deploy them, and what are some of the best practices that you can use. So before we go into that, here is a high-level overview of what the Lambda architecture block diagram looks like. Right, where you have your data source. It could be an IoT device. It could be something like your web server logs that's coming in, and then the data is being sent to both your batch processing and stream processing blocks. And from your stream processing blocks, you create the real-time views. And via your batch processing blocks, you create the batch views. And both these views will be merged at the merge layer. And from there on, the merge layer will actually power your dashboard, your queries, or even any further downstream analytics that you want to do. So diving in a little bit deep into the architecture. So the Lambda architecture consists of 3 layers: the batch layer, the speed layer, and the serving layer. So the batch layer is where you do all the heavy computation and heavy analysis, whereby you are actually focusing on the accuracy of the data, and you are probably, in most cases, taking the entire data set to do your comprehensive analysis to be 100%, close to 100% accuracy in whatever you're analyzing. So, for example, let's take the e-commerce platform, right? So, if you are trying, as part of the e-commerce platform, let's say if you are trying to analyze user traits, so you may be doing the heavy lifting of analyzing the data across all multiple dimensions. There may be tons and tons of dimensions that you want to analyze against to be able to have an accurate representation of the user trait. And for that, you may have to actually analyze a large set of data, maybe for every user, going back probably, let's say, the past 1 year or few years. And that all is done in the batch layer. So a batch layer is relatively slower. But what if you also want to be able to react to the current events, which is the clickstream data that's coming in, and let's say if you want to react to that and be able to provide recommendations to your users, and at the same time be able to have an acceptable level of accuracy in the user recommendation that you're doing. So for that, you can now actually refer the data from the batch layer and also combine the data from the real-time or the incremental view, and then do a merge query across both the layers. So that will give you both the accuracy, the acceptable accuracy, may not be as close to 100%, but the acceptable accuracy to be able to react to the immediate events that are coming in. So now let's look at how the batch layer can be deployed on AWS. And so if you look in the diagram, on the left-hand side is your data source. It could be any data, it could be your FTP server, or it could be any server, or it could be an IoT device that's actually streaming data into the landing bucket. And once it's there on the S3 bucket, now with Glue, which is a serverless managed ETL service, you can crawl the data, and if you're using the regular formats, say like JSON, Parquet, XML, Glue can automatically do your schema discovery. And you can also convert the data from one format to the other using Glue, so that it's more, maybe you improve your query performance. Let's say you move from CSV to Parquet or ORC. You do either a format translation, or it could be that you are prepping up the data so that you have the fields that you need for analysis. And all this the metadata can be stored in a Glue catalog. And with the Glue data catalog, now you can query the data using Amazon Athena, which is a interactive query service. And the language that you need is SQL. And then from Athena, you can connect to Athena from QuickSight, and then be able to visualize the data that is sitting in S3. The other method or approach that you can use is, let's say if you have a Spark or EMR or a Hive job that you already have, then you can refer again to the Glue metadata catalog and be able to query using your Spark, Hive, or other jobs that you have written, and write the data to S3, and then query that or visualize the data using Amazon QuickSight. This is the batch layer. The next layer is the speed layer, right? Here's where data is coming in. And now you can push the data to Amazon Kinesis Stream and using AWS Lambda. So this is not the Lambda architecture, this is the AWS Lambda service. You can write your function in Node.js, C#, Python, and be able to do minimal, right? Minimal processing of the data, and then pass it on over to Amazon Kinesis Firehose, which will actually stream the data to a persistent storage. And with Kinesis Analytics, you can do detections like anomaly detections, and you can run your analysis on the window of data that's being streamed in. So this is your real-time or near real-time streaming analytics or stream processing that's going on. So on the left side is your data source that's actually streaming in data. And then you can stream it to Kinesis Stream, and then you can do pre-processing with Lambda before it's being sent over to Kinesis Firehose. And with Kinesis Analytics, now you can actually be able to run your query, SQL-like queries, on top of the Kinesis Firehose. And Kinesis Firehose is also streaming your data to a persistence store. And then with Amazon EMR, you can, like if you're using Spark, Spark has a library to read off of Kinesis streams. And you can also run your Spark job on top of Kinesis stream and push your incremental view or your real-time view to the S3 bucket and then for visualization. So, and in this one, your focus is more about quickly being able to react to the data as it's coming in. Okay, with that, I'll hand over the next few slides to Ujjwal.
Okay. Thanks, Rajiv. Okay, so what Rajiv showed you were two specific architectures about batch and stream, right? So what I'm going to tell you about is how do you combine the two? Because ultimately what you want is a single architecture that you maintain. You don't want to maintain separate architectures to take you from batch to stream, and then, it's a hassle managing different environments. So what you essentially do is between your batch and your speed layer that Rajiv told you about, you create something called a serving layer. And the serving layer is typically designed in applications that allow you to process unstructured data quickly, because at one end in the batch layer, you would be designing jobs that are typically with structured data sets, right? So your data sources would be like databases, CSV files, but on the speed layer, your data structures are not very defined. So it might be the most you could probably expect is like a JSON file that has some sort of a structure, and an XML file, but it is still not something that's suitable for structured data set processing. So EMR is our Hadoop service, the managed Hadoop service that allows you to spin up an environment, and you can easily write my favorite language, Spark, queries on it that allows you to query the speed and the batch layer together, and then merge that into a merged view. You could have a merged view stage where you actually store all that merged records inside an S3 bucket, or you could directly read from the EMR and build visualizations on top of it. Another thing you could do is, if your architecture does not require that elaborate constructions of real-time view and batch view, and all you need is basically a way to ingest records from a batch layer and a speed layer and then combine the two, then you could go with something more simplistic. You could have the batch layer just reaching up to the Glue data catalog, which gives you the metadata repository on which all your queries are run. And you could have Kinesis just acting as a stream. So Kinesis has three flavors to it. It has the streams, the firehose, and analytics. And you can do away with firehose and analytics because it's all about batching data in certain intervals for both of those flavors of Kinesis, and just stick to streams, which is all about connecting to a streaming source, pulling data and messages, and then combining that all of that together into an EMR cluster that joins the two and serves it for visualization. And here's an example of how you could do that in Spark. So if you can see on the top, we've got the first query that is being generated by the batch layer. The batch layer is a simple data frame that reads from as a JSON from S3. The second box that you see over there is where the data is being created from the Kinesis stream. So that's my real-time query. And obviously, you might be thinking, oh, why is that real-time query being pinged only once? It'll give you, every time you actually ping that query, it'll give you a different result. So the whole idea is that there should be some sort of a way in which that query is continuously executed, maybe a cron job or something that allows you to ping that query regularly. And in the final box, you have the place where everything gets merged. So you could see the join is happening between the first query and the second query. And that join, to the use case that Rajiv took an example of, let's say a retail website. And we are known for our retail, right? So we know a thing or two about retail. But in the e-commerce website, let's say you're doing clickstream analysis, right? And that clickstream data is going to be combined with batch data of customer behavior analysis. In those cases, you would have the clickstream being merged together with the batch data in the last query, and that will give you a holistic view on which you can build predictors, machine learning models that will tell you, okay, what the customer behavior is going to be, what is he going to buy next, for example, right? The last thing we are going to touch upon is security, because that's job zero for us. We want to make sure that when you're deploying these architectures, you're secure. And one of the first things that we tell our customers is to kind of encrypt end-to-end. Utilize server-side encryptions wherever available. That's the least disruptive way of introducing encryptions in your environment. You also have various flavors of encryptions that we support, like KMS. You can have your own keys in KMS or use our provided keys. So there are various options to play around with, and most of this, all the servers actually we talked about today support encryption at some level. So as you can see, Lambda supports it. You can have encryption set up in the Lambda function configuration section. Kinesis obviously has native support for encryption. So you can pre-encrypt your messages and then put it in the stream, or utilize server-side encryption of a Kinesis stream to encrypt data on the fly. And then Athena also has configurations that allows you to read from encrypted S3 buckets. So all of these are best practices for A, building a Lambda architecture, and B, securing it. And one thing you might have noticed is most of the services that we chose here today are serverless. So that is why we did not have a slide about scaling, because by using serverless applications, you're not bound by the limits of your own infrastructure and the infrastructure you are deploying on. It's totally serverless, so you actually just have to write your code, run it on the AWS environment, and the AWS sort of takes the burden of scaling your environment as and when you need more capacity. So with that, I think we are at the time where we will take questions. So we have moderators in the room with mics, so please raise your hands and they will walk up to you and then you can ask your question. We'll get to most of them today.